Hi Dr. Hudson, I'm Matthew Yad, and this is my photosynthesis lab presentation. So over here at the top we have the light reactions or the light dependent reactions, and over here at the bottom we have the light independent or the dark reactions, or the carbon fixation cycle or the Calvin cycle. And we're going to start over here with the light reactions. So this is the thylakoid membrane right here, and right here is the inside the thylakoid space, and over here is the stroma. And I didn't label it, but all the Calvin cycle happens in the stroma. And so we start here with light coming into photosystem 2. We have photons of light coming in, and they bump around and transfer energy all the way to the special pair of chlorophyll molecules, and the combination of that with the oxygen evolving complex, also known as the water splitting complex over here, with 2 H2O giving off O2 and 4 hydrogen ions. The reaction center of chlorophyll A gives off an electron, and that electron is carried by plastoquinone over to cytochrome B6F complex, and while it goes through that, some hydrogens are transferred over to the thylakoid space side, so we have a lot of them aggregating over here. And then plastocyanin carries it over here, carries the electron over here to photosystem 1, and more light is needed to activate photosystem 1. And we have the electron going here. Ferredoxin carries it over to the ferredoxin NADPA reductase enzyme, and that enzyme takes in hydrogen, the electron NADP plus, and makes NADPH, which goes to the Calvin cycle. And over here, since we have the aggregation of H plus ions, we have ATP synthase to bring them back over here to the stroma, and when it does that, it allows ADP to phosphorylate with ATP to become ATP. And then over here, that brings us to the Calvin cycle. So in the Calvin cycle, we start with 3 1-carbon CO2 molecules and 3 5-carbon ribulose 1,5-bisphosphate molecules, and with the help of RUBP carboxylase or oxygenase, but in this case it's carboxylase, the enzyme helps make these 6 3-carbon 3-phosphoglycerate molecules, and then they go through a series of reactions which involves ATP going in to give off ADP and NADPH going and to give off NADP and a phosphate molecule. And these ATP and NADPH just come from the light reactions. And over here we have, and at the end of that it gives us 6 times 3-carbon glyceraldehyde 3-phosphate molecules. And one of the 6 goes over here to amino acids, sugars such as glucose and fatty acids. With the rest of them, the rest of the 5, they go over here and stay in the Calvin cycle with a 5-time glyceraldehyde 3-phosphate. And they go through lots of fancy chemistry where some phosphate molecules are given off and ATP goes in and ADP is given off. But basically they change it from 5 3-carbon molecules to 3 5-carbon molecules, and we have 3 times ribulose 1,5-bisphosphate, which is a 5-carbon molecule, which is one of our starting substrates at the beginning. So that just goes right back into another cycle. It goes around 3 times, I believe, and then it starts over again. So that's it for my presentation video. I hope you enjoyed. Thank you.